So, so strain measurement is going to be the topic of today's video, and this entire lecture and the next lecture as well. So the reason engineers are so interested in measuring strain is because engineers are typically, when they create a design, they're trying to design systems that will not fail due to mechanical loading. Okay, so all different types of structures we design to not fail due to mechanical loading, and all of these analyses are based off of all these designs are based off of stress analysis, right? Stress analysis is introduced in MME 312, Mechanics of Materials. Also talks about in Advanced Mechanics of Materials, and throughout a lot of courses. Talked a little bit about it in Material Science as well. All right. However, we can't if we have a component we can't directly measure stress on the component, but we can directly measure strain, or the change in length over the original length within a structure. Alright? So if the strain within a structure is known, we can convert that to stress to predict failure. Alright? And if you haven't taken material science or haven't thought about material science in a while, the basic idea of failure criteria is that if you have a stress is greater than the yield strength, failure occurs. If the stress is less than the yield strength of the material, the failure will not occur. Alright? So all we're interested in doing in today's lectures are we're going to determine what the strain is based off of a strain gauge measurement, convert that to a stress, alright, using probably the Young's modulus and the Poisson's ratio of that material. Alright? And if the stress, we're going to compare that stress to a material property, typically the yield strength or the ultimate strength of that material. And if the stress is greater than the yield or the ultimate strength, we have failure. If not, the material that we're investigating or the product that we're investigating would not fail under the applied mechanical load.